So again, we had the original black shape that's vertices were at 5, 2, 5, 4, 3, 4, and the first reflection was supposed to be across the x-axis. So that meant the x's didn't change, but the signs on the y's did change. So remember, a reflection is the same as a flip. So the shape doesn't stay in the same orientation, it actually changes the orientation. All right. Everybody got that one? So next what we want to do, B, says take your ordered pairs, and now you're going to subtract 3 from the x-coordinate, but you're going to keep the y-coordinate the same. So if I keep the 5, I have to take 3 away from it. 5 take away 3 is 2, and I keep the y at -2. So I'm going to go 2, -2. The 5, -4, I'm going to take the 5 and subtract 3 from it, and that gives me a 2, but I'm going to keep the y at -4. So I have 2, -4. On the 3, 4, I'm going to subtract 3 from the 3, which gives me 0. And then the -4 stays the same. So that gives me this point here. All right, that's enough. I'm sorry. And this point was at 2, -4. So now this is our triangle B. Okay. So again, we didn't go to the original one. Matthew, you're not working. You didn't go back to the original one. You went to the transformation we just made. All right, C says we're going to take B and we're going to reflect it across the y-axis. So how does reflecting over the y-axis change our ordered pairs? Sarah? So y doesn't change, but x becomes negative. So if we look at this point 0, -4, we're going to take the x and make it negative. -0 is 0, but we're going to keep the y the same. So the weird thing on this guy is it's the same point. And then we're going to take the 2, -4, we're going to take the 2 and make it a -2, but we're going to keep the -4, -4. So we -2, -4. And then the 2, -2, we're going to take the opposite of 2, which is -2, and keep the y value, which is -2. So we're here at -2, -2. And now we have construction, or transformation C. Okay. Matthew, you got to stop daydreaming. You got to work on the next one. Yeah. That's been helping, huh? Yeah. So then D says take those coordinates, keep the x the same, but now I want you to add 4 to the y value. Okay, so the 0, -4, I keep 0, 0, but now I'm going to take -4 and add 4 to it. So what does that give me? What's -4 plus 4? 0. So I end up with this point that's on the axis at 0, -4, now ends up at 0, 0. And -2, -4, the -2 stays the same, but now I need to add 4 to -4, and what does that give me? 0. So I'm at -2, 4. I mean -2, 0, sorry. And the -2, -2, I'm going to keep the -2 for the x, but on the y, what's -2 plus 4? 2. So that's going to take me -2, +2. So then we draw that picture. Oops. And we label that D. All right, we got one more transformation to make. Now this you might need to go back to your notes. Remember how we took notes on the algebraic representation of a translation, a reflection, and a rotation? Well, we're going to talk about that rotation. So if you can find that set of notes on the algebraic representations and look for your rotations. The last one we're going to do is a 90-degree rotation clockwise. So we're going to take x, y, and what does clockwise tell us to do to the coordinates when we do the rotation 90 degrees? So if you go back and look through your notes, should be one of the last set of notes that we took. Okay, it was on the algebraic representations. I think it was not even the last week before break, it was the week before that. What does it say that we're going to do with our x and y? Cleo? Okay, so the y now gets in the x spot, and the x goes into the y spot, and we have to multiply it by a -1. So we're going to change the x sign, and we're going to swap the location of the two coordinates. Okay, so let's see how that's going to happen. Now 0, 0 is easy, right? I can swap 0, 0, and I still have 0, 0, and I can multiply 0 by negative, and I still get 0. So this point is still here at 0, 0. Okay, now the -2, 0. We have two ways to do it. We can swap first, which I like to do, and have 0, -2, and then take the x value, -2, and multiply it by -1. So what's -2 times -1? -2 times -1? +2. So we're going to be graphing 0, 2. And then we have -2, 2. So we're going to swap 2, -2, and then we're going to take the -2 and multiply it by -1. And -2 times -1 is +2. So we're at 2, 2 on that one. Oops, 2. And that's the last one, E. Now, F asks us the question, and if we were really accurate about how we made our drawings, it says compare the size and shape of the final image, so E, to the original figure. What do you notice is true about the orange in terms of size and shape to the black? What should it be? Because some of you, again, kind of drew it and you had little dinky things compared to what you started with. What do we talk about transformations? All three of these transformations. What does the end result look like compared to the beginning? Same shape, same size, and the word that means that is congruent. So we end up with congruent shapes when it comes to these particular types of transformations. When we talk about dilations, we are not going to get congruent shapes. We are not going to get congruent shapes because we're taking something and shrinking it or taking something and enlarging it. So they are not the same size. They may be the same shape, but they're not going to be the same size, so they're no longer called congruent. They'll be called something else. Okay? All right, and then the other question they asked under reflect is, which transformations change the orientation of figures? So did we have an orientation change from the original to A? So looking at the black, did the orientation of the figure change when I went to A? Yeah, notice you had a flat top, and here you have a flat bottom. So that's a definite orientation change. How about from A to B, was there a change? Yes. No. How about B to C? Yes. Yes, that one again, another reflection. How about from C to D? No. No. How about D to E? Yes. Okay. Now, what's kind of interesting is that if you compared the original to all of these, is there any other shape we got that's exactly the same orientation-wise as the original? No, all of them changed. But some of them were similar to others, like these two were similar to each other, these two were similar to each other. E also had no other partner that he looked exactly like. And that rotation kind of throws things off, okay? All right. So I'm going to go to the next page, and let's see if I can recreate this one. Oops. Let's see, how far do I need to go? Let's go up to 5. I was hoping I was going to be able to go 2, but I can't. So I'm going to label every other number the evens. X-axis, Y-axis. And we're going to go from A and we're going to go to B. So A's at negative 2, 2. And we go negative 2, 5. And negative 4, 5. What kind of triangle is that, by the way? Right triangle, right? Okay. And then B shows up at 5, negative 1. So let me give him a different color. And at 5, negative 3. And 2, negative 3. So what I want to do is try to figure out what types of transformations took place to get A to shift into the same position as B. So sometimes it's easy to track a point. So I'm going to do that. So I'm going to take this point here, and he's at the negative 2, 2. And then his counterpart is here, and he's at 2, negative 3. Okay, so what do you think we did? Is it oriented the same way? No. So I can't do that just by translating, right? Because all that does is slide things. Keeps the orientation the same. So what are my choices with orientation change? It could be a rotation. What else? Could be a reflection. Okay, so reflection just flips the image. Is this image just flipped? No. So it looks like we have a rotation going on. So what direction are we rotating? Okay, so it looks like we've got a rotation, a 90 degrees clockwise rotation. And that would tell us, take your X and Y, and what happened to your ordered pairs when you do a rotation. We've already talked about this one. Do you remember? Not clockwise. I like that you did get the, we do have to swap spots. Yeah, that's the X that's going to become negative. So that means this point here that's at negative 2, 2 becomes 2, negative 2, but then the negative 2 becomes a positive 2. So we're going to take him to 2, 2. Okay. And then the negative 2, 5, 5, negative 2, and the negative 2 we change. So he's going to go 5, 2. And then this point's at negative 4, 5. So we're going to swap, and we have 5, negative 4, and then negative 4 is going to become positive 4. So we go 5, 4. So that's what the intermediate rotation would look like. Now, how do I get, and let's just pick this point here. He's at 2, 2. What am I going to do to get him to this point? So the first was the clockwise rotation. What you got?
Translate them down.
Okay, so tell me exactly how to do that. So now we're this. Does the X value change? I went from 2 to 2, so the X value stayed X. But how do I go from 2 to negative 3?
The y equals negative
How much, though?
5.
Okay, so I'm going to have to subtract 5 from the y value. Okay, now when I talk about x and y value, I'm talking about what I have in the red. That's my intermediate stage. So those were my two translations. So I did a 90 degrees clockwise rotation that switched my x and y and made my x negative, and then I had a translation where the x value stayed the same, but then I subtracted 5 from the y value. You writing this all down, Sean? Because that's what your homework is going to be tonight. And because you guys have been doing such a good job, we're going to do one of your homework problems together. But you're going to need graph paper, so if you don't have any, come get yourself one right now. All right, so this one we're going to do is very similar to the very first activity, which we're going to take this shape, this rectangle, and we're going to do 5 different translations to it. And we're going to label each translation with its letter. So this is homework problem number 1. On 2, 3, 4, and 5, you don't have to do any drawing. You just need to answer what you see from the diagram. And then you guys are going to do the next page, the independent practice. You're going to want to use graph paper on 7, 8, 9, and 10. Okay? So let's go ahead and we'll do this one together. So on your graph paper, I would say just keep to the upper half, and I would be drawing in my x-axis and my y-axis. We're going to go to 6 on each of the axes. Now, if you want to count over by every 2 boxes to count as one, you may do that. I just don't have enough room on the vertical for me to do that. But we're going to go to 6, up, down, right, left. Make sure you label at least every other number. And then we're going to draw in our rectangle. Can you guys tell me what the coordinates are? Oh, how about if I call on 4 different people and you give me a different vertex, and then I'll draw it in here. So let's deal with Cameron. Can you give me one of the vertices of that rectangle?
-1, 4.
Okay. So -1, 4. And then Mackenzie, can you give me another one?
-1, 3.
-1, 3. And let's see. Who did I talk to? Madison. Maddie, give me another one.
-4, 3.
-4, 3. And Adam, how about the last one? Looks like top left.
I'm on the wrong page.
We're on page 308. Number 1. What are the coordinates of top left? Okay, -4, 4. All right, so this is where we're all starting with this guy. Oops. Okay, so reflection A says we're going to take this and we're going to reflect it over the y-axis. So if we take our coordinates and we're going to reflect it over the y-axis, what are we going to actually do with our coordinates? Do they switch? Do they stay the same sign? Do they change signs, Pete?
Switch.
Okay, so y becomes x, x becomes y? We're just doing a reflection across the y-axis.
Oh, the x becomes positive.
It already is positive. So we're just going to generic up in the upper left where our two coordinates are x, y. So now what would the coordinates generically look like when we reflect over the y-axis?
They're the same.
Well, if they're exactly the same, then wouldn't I end up in exactly the same spot? Something's got to change. What did you say was going to change? The x's. So we're going to just, to show change, we're going to put a sign there. So we're going to take our x values and we're going to make them negative. Okay? So we had negative 1, 3 becomes 1, 3. Negative 1, 4 becomes positive 1, 4. Negative 4, 3 becomes positive 4, 3. And negative 4, positive 4 becomes positive 4, positive 4. And we're going to label that A. Okay? When I do B, I'm going to do it to A. I'm not going to go back to the black origin. I'm going to go from A. So to go to doing a rotation clockwise, we're going to start with our coordinates that, well, I'll just call them x, y. And now they're going to become what? What happens when I rotate clockwise 90 degrees? What do I...
Y negative 6. I mean, the x negative y. Y negative x.
Y negative... Okay. There we go. We'd get it eventually. All right, so we're going to keep the y value but put it in the x spot, and we're going to take the x value and take its sign opposite and put it in the y spot. Okay, so let's see. I'm at 1, 3, so I'm going to change it to 3, 1, and then change from 1 to negative 1. So I'm going to go 3, negative 1. This guy, we had 4, 3, so I'm going to swap 3, 4, but the 4 becomes negative, so it's 3, negative 4. Up here we had 4, 4. I'm going to swap them 4, 4, but then take and make the x negative, so it's going to be 4, negative 4. And this last spot we had 1, 4. I'm going to swap, make it 4, 1, and the 1 becomes negative, so now it's 4, negative 1. So there's my B. All right, so now I'm going to take that value I just had. Now those coordinates are called x, y. And now what I'm going to do is take 2 away from the x but keep the y the same. So if I have an x of 3 and I take 2 away from it, it's going to give me an x of what? 3 take away 2 is 1. Now it stays on the same level as it was before, so it's going to just shift over there. And 4 take away 2 is 2, so we're going to have 2, negative 1 over here. And then we had another 3, take away 2 is 1, so we're down here over at the negative 4, and then the same thing over here. So we just did a translation to the left. That's C. D says now we're going to take that guy and we're going to rotate him counterclockwise around the origin. And that's where we're going to stop.